Okay, these examples are some practice with finding derivatives of functions related to e to the x. So you see we have two rules here. The derivative of e to the x is e to the x. Of course, that's a nice, pretty easy rule to use. But then a little bit more general one. The derivative with respect to x of e to the power u is e to the power u times the derivative of u with respect to x. Okay, basically, if you're taking the derivative of just e to the power x with respect to x, you use this rule. Okay, but if you're taking the derivative of e to any other power, anything that's more complicated than x, and you're taking that derivative with respect to x, you need this rule. Okay, so this rule over on the left, we won't probably use it quite often because obviously it only applies to one single function. But let's look at this function. F of x equals e to the power 3x squared plus 5. Okay, so you're asked to find the derivative of that. Well, that's going to be the second rule. So what we look over here is that, this function we have is actually e to the power u for u equals 3x squared plus 5. Okay, so, if we replace that power and called it u, then u would have to be 3x squared plus 5. Okay, so we can use the second rule, and actually you can probably just write this down now that you've had some practice with computing basic derivatives. The answer of taking the derivative with respect to x of e to any power is just e to that power, so e to the power 3x squared plus 5, times the derivative of the power, u. Okay, so I look over here and I say, well, what is the derivative of 3x squared plus 5? Well, you can take the derivative of each term separately. We have to use a couple of basic rules, but that's just 6x. So if you want the answer, this is the answer, but you could probably write it 6x times e to the power 3x squared plus 5. Okay, and that's it. Okay, so let's look at another one here. G of x equals x e to the x, or x times e to the x. And again, the question is, what's the derivative of this function? Okay. Well, actually, if you look at the power of e we have, it is just e to the power x. So we will be able to use this nice, simpler rule. Okay. But that's not all the function is. It's x times e to the x. And the rules for derivatives say if you actually multiply two functions together, okay, and neither of them are constants, you have to use the product rule. Okay, so the product rule says, and again here we are multiplying two functions together, two simpler functions, x and e to the power x. Okay, so the product rule requires you kind of put four things in here. It says, we take the derivative of the first function, which is 1, okay, derivative of x is 1, okay, and multiply it by the second function, e to the x, okay, and then to that we add the first function, x, times the derivative of the second. Well, the derivative of e to the x, we can just use this simple rule here, it's just e to the x. Okay. Oops, there we go. Okay. Okay, so this is what we have. So g prime of x, the derivative of the function we started with is just 1 times e to the x, so e to the x plus x times e to the x. And in the back of the book on one like this, they might factor out the e to the x and write it as 1 plus x times e to the x, just distributing or factoring out that e to the x power. Okay, but either of these answers is technically okay. Okay, so let's do one more here, and you can kind of see it's very similar to some of the ones we've had already, but the power of e is just e to the power 2t, not a very difficult one to compute, but the entire function is e to the power 2t over t squared plus 1. Okay, so of course the first thing you see is this big fraction, and for fractions you have to use the quotient rule. So if I go over here and I try to find the derivative, h prime of t, okay, well, we're going to set up the quotient rule, and if you remember the quotient rule, you multiply two things together and then subtract the product of two other things, and you divide by something squared. Okay, so what does the quotient rule say? It says, well, take the derivative of the numerator, okay, and that's the hardest one to do. What is the derivative of e to the 2t? Okay, now since t is the variable, we're taking the derivative with respect to t. So you can kind of think of this as e to the power u, where u is 2t. Okay, So the derivative of e to the power u is e to the power u, so e to the 2t, okay, times the derivative of u, in this case with respect to t, so that'll be 2. Okay, so that's the derivative of the numerator, and then the quotient rule, we multiply that by the denominator, so I'll kind of tuck this in here, t squared plus 1, okay, and then we subtract the numerator, okay, times the derivative of the denominator, which is just 2t, okay, not a very difficult one there, and divide by the denominator squared. So I'm dividing by t squared plus 1, that whole quantity squared. Okay, so maybe I can simplify this one a little bit. H prime of t, well, I can multiply, I have two terms in the second parentheses here, so I can distribute. It looks like I'll get 2t squared e to the 2t plus 2 e to the 2t. Okay, so I just took the 2 e to the 2t, multiplied it by t squared, and then took 2 e to the 2t times 1, get this. And now I need to subtract this product, and so that's going to be minus 2t e to the 2t. Okay, all over t squared plus 1 squared. Okay, now in the book on this, and something you have to be kind of careful when you're writing a final answer, you know, can it be simplified? Well, I'd say technically this can't really be simplified. Typically we try to factor something if factors will cancel. We might go ahead and try that. The numerator does factor. I can factor an e to the 2t out of every term, and I can also factor a 2 out of every term. So if I factor out 2 e to the 2t, I'll have t squared plus 1 minus t. So let's write it this way, plus 1 minus t. Okay, that's all over t squared plus 1, okay, squared. Okay, well, unfortunately you can maybe try factoring this, but it's pretty clear the denominator, if you remember, this one doesn't factor. So since these things don't factor, they're, you know, basically we can't cancel anything. So, you know, this is certainly okay for a final answer. Probably the one right above is acceptable as well. You know, again, we only typically factor something if it's going to help us cancel or, you know, reduce the number of terms. So this is okay for a final answer for sure.